Great. Let us open up the camera. Fantastic. Great. And great, we're now in the camera. So let's walk through end to end how to set up a recipe. Awesome. Let's call this segmentation demo exposed wire. And type is going to be segmentation, obviously. Great. So let's activate the recipe. And once we're in here, we work from left to right. And we go through each in turn. So first off, we got to set up our imaging, make sure we can see what we want to see. So first off, let's just turn that light up a little bit, make it a little bit brighter. Great. Let's get the image more focused. How about that? So we can see the wood grain really well. That was a little too much. That's pretty good. That's really good. Okay, cool. I'm happy. Let's do it. So in like a wire braiding example case, we got a lot of levers that we can play with. We can turn up the exposure, but I don't really like that glare that much. So we can leave it like that. That's good. We can increase the contrast. Ooh, I like that a little bit better. That's fantastic. We can turn up the light. That was fine. That's better. Cool. Great. We have an image. So image settings, you're basically like playing around with stuff until you find the right settings. That lets in a lot more light. That lets in a lot less light. I'll put it back to where it was. Cool. And then with your template image, you can set up an alignment tool. An alignment tool is tracking edges to basically follow where things are located. And you don't really use those in exposed wire, applications. It's more so if things are like coming down a conveyor and when a certain part comes into view, you want to take a picture. So in this case, we can actually skip it even faster. Boom. Great. And then let's set up our inspection. I'll call this wire. Maybe I'll call it wood. That makes more sense. People will be less confused. Great. And then here, we can put our boxes around the wire. And just do it like so. Cool. Fantastic. And then if you want to, I can align them, make them look really nice. Great. That is beautiful. And we're already done. All the ROIs, regions of interest are named. And now all we do is we label defects. So this one, let's just use this as a good example. Perfect. And maybe use this as another good example. So we teach the AI some different ones. And now let me just make some markings here. And do this. How about that? Great. And so to use the segmenter tool, all you're doing is you're just labeling what these different defects are. So here, we're just using a brush tool and following that right along. Perfect. Then we can move it around and keep labeling defects. If I want to, I can decide whether I want to label that super faint bit or not. I'll decide not to, just to reduce overmarks. Label that, and I'll label this guy right here. Great. And all we need is 4 defects to get started with the segmentation model. And then I am going to start training it. That is all we need to get started. We have all these advanced modes where we can rotate the image, we can flip it if we want, we can add different like noise levels that simulate real world production issues. We can simulate lighting changes, which are actually really useful, and color changes. Super useful, actually. Great. And then I can start training it. And this isn't the most, this usually takes a little second to warm up and get started. Takes anywhere from like 3 to 8 minutes. This first stage isn't that interesting. And maybe I can see if I can pause the recording and show you the more interesting bits in a second. So now we're back into an interesting part of the demo. Let us go to the batch preview. So we can actually track what the accuracy changes are and the training loss in real time. So we can start to watch as the AI trains itself on each iteration of training images. So what we see here is blue is what our labels were, green is what the AI guessed right, and red is what the AI overmarked or guessed wrong. And so towards the end of this, we should watch everything go green, and we'll see less and less of blue and red. And if we see that, then we know we'll have a pretty accurate inspection. Great. And so you can start to see those AI augmentations take place where it's the same images, but like under different color settings, slightly rotated. And this is just to help teach it what the real defects are, not what the noise is. And so far, this is looking pretty solid. This is not too bad at all. Great. I'm already pretty happy with this, but it'll keep training for a little while. And if we're anywhere above 91 to 99% accurate, we're in a pretty good spot. And you can start to see that accuracy level out and that training loss level out as well. And I expect by the end of this, we'll probably end up at about 95, 96%. But either way, what we're seeing so far is pretty good. And so you can just teach that as what exposed wire looks like. You just draw some examples of, of what, bad wire looks like and what good wire looks like. If anything's sticking out or what these defects look like, you can just teach the AI and maybe add different classes. You can add classes for extrusion defects like dimples and holes or extra material flash or exposed wire, things like that. Great, so now we're done. Ended at 94. Now it'll be optimizing for a little bit and then finish up. And then we'll have taught the AI what these defects are. We can see how accurate it is and test it on some other defects it'll draw. And then we can write the pass-fail criteria. Great, so now it'll go into optimizing, and this usually takes a little bit too. Warming up and optimizing are usually the longest steps. Boom. All right, we'll be finishing up shortly. Cool. I did bump up to 96%. That's fantastic. Cool. Okay, so now we're back. And that's what the defects look like. Beautiful. So if we just take a picture here, we're going to capture all these defects, and it's giving a correct fail. But if we move this, it's not seeing any defects, but it'll still fail. Oh, it's catching that a little bit, which it actually should, because that looks pretty similar to real defects. So, but it's still failing. That is because we haven't set our pass-fail criteria yet. So I'm going to set that really quickly. And we have a basic mode, and we can just set that in all these different regions. We can't see any, an area of, fail defects that's bigger than, we need to see less than 30 pixels of good stuff. Cool. And now if we go back to the HMI right here, that should pass. Great. But if we go back over here, they should fail. Lovely. So now we set that up. Let's test it on some other defects. What if I draw something like cool. It caught it. Let me get rid of those labels. Look at that. Not too bad for an AI with four training images. Let's flip this. This is a different style of wood. It's the backside. And let's see what that looks like. Not too bad at all. Off the gate, not too bad at all. Great. And now if you're looking at this constantly, we know how much what the cycle time is. You know, it's around 300 milliseconds. Great. Well, and usually I'll have wire moving through there relatively quickly. So I can just go on an interval trigger, set the interval to about like 500 milliseconds. And if I do this really quickly, I'm going to set some stuff up too. I got my logic here. This is going to be quick and maybe a little bit advanced, but I'm just doing this for me. And this is going to go to inspection pass fail. We need an inspection pass fail node to send an output back. And I'm going to just quickly set up logic so that if I receive an inspection pass, that I don't save the image because I don't need to. And that will be material for another video to go in depth on. And great. So now we can go to the HMI page. And these are fails, so it's just taking an image every time. Great, fantastic, beautiful, and that's a pass. Amazing. It's catching everything the way it should. And now we're done. Fantastic. One loves this. The AI is doing what the AI should do. Beautiful. So now if we go in the library, we should only see the failing images because I set it up so that it'll only save failing images to the library and not overload it with all these passing images. Then I can add more rules to this too, that it only saves like the first handful of failing images that it sees. Great. Okay. So that can conclude this demo. And I'm going to turn this interval trigger off for now. Great. So now you know how to set up a segmentation inspection. Lovely. See you later.